Okay, so in this lesson, we're going to continue our study of the rational zero theorem. Now remember, the rational zero theorem allowed you to list the possible rational zeros of a polynomial function. So that was in a previous lesson. In this lesson, we're going to actually find the rational zeros, and it's going to be for a cubic function. In the next lesson or a lesson after that, it will be a function that has degree 4 or larger. But for this lesson, we're just going to focus on a cubic function. Now, in Canvas, I need for you to make sure you have a copy of this. So this is finding the rational zeros of a polynomial. And so they're basically 3 steps, although step 3 will repeat. So the first step is to find the possible zeros. And so you learned how to do that in the previous lesson. So you list all possible rational zeros using the rational zeros theorem. The second thing you're going to do is you're going to use synthetic division to evaluate the polynomial at each of the candidates for the rational zeros that you find in step 1. So all you got to do is find one of them. Just find one rational zero that works. When the remainder is 0, then note the quotient that you have obtained. So we're going to look at the quotient to get a remainder of 0. When you find one that actually is a 0. Then you're going to repeat steps 1 and 2 for the quotient. Stop when you reach a quotient that's quadratic. And the reason is because either it's factorable, or if it's not factorable, you can use a quadratic formula, and then that will give you your zeros, or a function that factors easily, and use a quadratic formula factor to find the remaining zeros. Okay, so you can see how this is going to work. It's very simple. Do not get worried about this. It's a very simple process. So we're going to look at an example. Okay, so example 1 says this. Find the rational zeros of this function. And so you have this cubic function, 4x cubed minus 5x squared minus 7x plus 2. And remember, we're only looking for rational zeros here. So remember, a real number is either rational or irrational. So it could be that this function has irrational zeros, but we only want to look at the rational zeros in this lesson. Okay, in a future lesson, we're going to look at both the rational and irrational, but we're just interested in the rational. Okay, so the first thing you're going to do, remember the first step 1, is you're going to list all possible rational zeros using the rational zeros theorem. All right, so remember how we did this. So first of all, your possible rational zeros are, and remember, remember P divided by Q. So where P would be the factors of the constant term, so that would be the factors of 2. So the factors of 2. And then the denominator would be the factors of your leading term. Remember, leading term it does not mean the first term you see. It's the leading term. The leading coefficient is the coefficient of the largest degree term. So that'll be cubed here. So the leading coefficient is 4. So the factors are 4. All right, and so we get plus or minus 1, plus or minus 2, and then the factors of 4 would be plus or minus 1, plus or minus 2, and plus or minus 4. All right, now remember what you did next was you actually wrote this in a different way. So the possible rational zeros are, remember how we did this? Plus or minus 1 divided by each of these, and plus or minus 2 divided by each of these. All right. Now, so in the previous lesson, we actually listed all those. Remember that? So I'm just going to go ahead and actually write out what they are in lowest terms. So plus or minus 1 divided by plus or minus 1 is plus or minus 1. Plus or minus 1 divided by plus or minus 2 is plus or minus 1/2. 1 divided by 2, right? And then 1 divided by 4. So the next one is plus or minus 1/4. I'm not going to have enough room here, so I'm going to list it underneath. Then go to the next one. Plus or minus 2 divided by plus or minus 1 is plus or minus 2. Plus or minus 2 divided by plus or minus 2, so 2 divided by 2 is 1, right? You already have it listed. And then 2 divided by 4 reduced in lowest terms is 1/2. have. We already have it listed. So these are the possible rational zeros. Okay? All right, so here's your step one. So we did step one. So step one was to list all the possible rational zeros using the rational zeros theorem. Now, what we got to do next is we got to find one of these that works, if there are any. All right, so we got to find one that works. Okay, so well, it's cubic, so there will be there should be one that works. So let's see. Let's try one. Let's see if one works. All right. Most students navigate to the smallest integer. So one. So let's see if one works. So we're going to use synthetic division. So that will be part step two. Use synthetic division to evaluate each of those rational zeros until we find one that works. Okay. So let's try one using synthetic division. Now remember, when using synthetic division, if there's any missing term, you got to use zero. Remember that? And it's got to be in descending order. So it's already in descending order, and I don't have any missing terms. So 4, -5, -7, 2. So remember, you bring on the 4, and then you multiply. 4 times 1 is 4. Then you add. We get -5 plus 4 is -1. Then you multiply. 1 times -1 is -1. Then we add. -7 plus a -1 is -8. Then we multiply. 1 times -8 is -8. We add, we get -6. So notice the remainder is -6, right? The remainder is -6. So that means that 1 is not a 0. 1 is not a 0, since remainder is not 0. Okay? So then we got to find one that works. So one didn't work, so let's try something else. Now you may say, well, good Lord, there's 2, 4, 6, 8. There are 8 of those, right? So there's 8. So which one should I do next? Guys, there is no easy way. It's just trial and error. You just pick one, and if it works, you're good to go. You just got to keep doing this trial and error. All right, so one did not work, so we'll try something else. Most students will navigate to the integers. They'll leave the fractions alone for right now because they don't like dealing with fractions, and that's fine. But it may be that your fraction may be the one that works, may be the only one that works. All right, so just be a little bit careful in what you choose. But yeah, there is no easy way to determine which of these actually is a 0, other than graphing the function, which in this course you don't have access to a graphing calculator. So let's try another one. Let's try +2. Let's see if 2 works. So we're going to try 2. So again, synthetic division. So 4, -5, -7, 2. All right, so we ran on a 4. 4 times 2 is 8. When we add -5 and 8, we get 3. 4 times 2 is 6. When we add, we get -1. -7 plus 6, -1. When we multiply, 2 times -1 is -2. Oh, look at this. We got one. So 2 is a 0. All right, so 2 is a 0. All right, so we found one. We found one that works. So I found, no, remember one of our theorems said that the degree is 3, right? So we have at most 3 real zeros. Now remember, real numbers either rational or irrational. So it could be, see, I found one rational 0. It could be the other 2 are irrational, right? Or it could be that the other 2 are complex zeros. All right, so all we're interested in finding here is just a rational one. So we got to find, of all these listed, which ones work. All right, now here's the good thing about this. Don't do this anymore. Don't do this anymore, because you now know this. You now know, see, this was cubic, right? Okay, so we now know this, and this is kind of part of step 2. So step 2 says use synthetic division to evaluate a polynomial. So when the remainder is 0, note the quotient you have obtained. So I want you to look at the quotient. This is your quotient right here. Now remember when we talked about this in a previous lesson? So this is cubic, then this would be 4x squared, right? So it goes by 1 degree lower. Then this is 3x, and that's your constant. All right, so what I want you to think about is this. Do y'all agree, based on all the lessons we've done with this, that f of x, which equals 4x cubed minus 5x squared minus 7x plus 2, is equal to, now remember when you did this long division, this is what we ended up with. I'm going to go ahead and write it over here. So remember, you tried x equal 2, so that means x minus 2 is your divisor. And then your dividend, remember, was 4x cubed minus 5x squared minus 7x plus 2, right? Oh, I'm sorry, right here. So x minus 2, and then 4x cubed minus 5x squared minus 7x plus 2. So this is your quotient, right? That's your quotient. Well, that's this right here. That's this. So if you were to do this using long division, what you would end up here would be 4x squared plus 3x minus 1. That's what you ended up with. And so this right here would be this times this, plus your remainder, which we know is 0. Okay, the remainder is 0. So this will equal this times this. So what I'm trying to say is this. This right here will be x minus 2, the linear factor, times 4x squared plus 3x minus 1. And now all we have to do is find the zeros of this. See, this is now quadratic, and that's what this is saying. So this says repeat steps 1 and 2 for the quotient. So here's your quotient. Stop when you reach a quotient that is quadratic or factors easily. So let's see if we can factor this. So let's try. So we get x minus 2 times, and if it's not factorable, we're going to use the quadratic formula. But let's see what would work. So let's try 4x and x. I think that's going to work. The last sign's negative, so one of these is positive, one's negative. And let's put the 1 here and the 1 there. And let's make, and so this would have to be plus, and this would have to be minus. And let's double check. 4x times x is 4x squared. Negative 1 times positive 1 is negative 1. The outer is a positive 4x. The inner is a negative 1x, and you get 3x. And there you go. So you factored. And so now your zeros, to find your zeros, set each factor equal to 0. We already found one, right? So one of them is 2. So that's this one right here. So x minus 2 equals 0, so x is 2. There's one of them. 4x minus 1 equals 0, so x is 1/4. And that was this one right here, right? That was 1/4. Most students would not go to this one to try it. They navigate to the integers. And then x plus 1 equals 0, so x is negative 1. So there's the other one. So those are your three, your rational zeros. Now, your degree is 3. So there is a theorem that we're gonna talk about later on that says that if the degree of your polynomial will tell you how many zeros there are. So notice there are 3 right here. The degree is 3, so you have 3 zeros. 1, 2, 3. They're all rational. All right, so that's it, and that's how you do this. So the more problems you do with this, the easier it becomes. The only tricky part is finding that first one that works. So once you find the one that works, remember we're dealing with cubic. So once you find one that works, then you rewrite it as that linear factor times the quadratic. So that quotient here, your quotient is going to be quadratic, because we're only focusing on cubic functions in this lesson. Okay? All right, so let's look at another problem. Example 2. Okay, so we want to find all the rational zeros of this cubic function. And so we have at most 3 real zeros. They could all be rational. They could be rational, irrational, combination of those. They could be, one of them could be real, or 2 could be complex. Okay? So you have all these possibilities, but all I'm interested in is the rational ones. I just want to find the rational in this lesson. Later on, we're going to look at the other zeros, but for this is just rational. Okay, so remember the first step you're going to do is you're going to list your possible zeros using the rational zeros theorem. All right, so let's go ahead and do that. All right, so the possible rational zeros. possible rational zeros. So remember, it's the factor. The numerator will be the factors of your constant term, so factors of 3. And the denominator would be the coefficient, the factors of the coefficient of the leading term, which in this case is 2. So the factors of 2. So we get plus and minus 1, plus and minus 3. Factors of 2, plus and minus 1, plus and minus 2. All right, so let's go ahead and rewrite this. So the possible rational zeros are, okay, 1 divided by 1 is 1, so plus and minus 1. 1 divided by 2 is 1/2, plus and minus 1/2. 3 divided by 1 is 3, plus and minus 3. And then 3 divided by 2 is 3/2, so plus and minus 3/2. All right, so I have 2, 4, 6, 8. I have 8 possibilities. Now, obviously, at most I can have is 3, right? At most I can have is 3. Okay, so remember, most students will navigate to the integers first, and that's fine. But keep in mind, you're only, if there, let's say there's only one rational zero. It could be a fraction. Okay, just keep that in mind. But most students will navigate to the integers first. So they'll try plus or minus 1, plus or minus 3 before they'll even try the fractions. So remember, there's no easy way. It's just trial and error. You got to find one that works. Once you find one that works, it's cubic. Once you find one that works, then finding the other zeros is easy because you can either factor, if it's factorable, or use a quadratic formula. Okay? All right, so here we go. So let's try one. Let's try one, see if one works. So now remember, we're using synthetic division, so that's your step 2. Use synthetic division to evaluate the polynomial at each of the candidates for rational zeros that you found in step 1. When the remainder is 0, let's look at the quotient. So let's let's try one. Notice that it is in descending order. There are no missing terms. Remember, if there's a missing term, you put a 0, right? Okay. So we have 2, 3, -8, 3. All right, bring on the 2, we multiply. 1 times 2 is 2. Add, 3 and 2 is 5. Multiply, 1 times 5 is 5. Add, -8 plus 5 is -3. Multiply, 1 times -3 is -3. Oh, here we go. We got it already. So 1 is a 0. Okay? So since 1 is a 0, that means a factor is x minus 1. That's what that means. Okay. All right. So now what we're going to do, since we found a 0, let's look at the quotient. All right. Now remember, this is cubic. This is cubic. So what that means is that this will be your quotient right here. So we have, so since that was x cubed, then this has to be x squared, and this has to be x, and there's your constant. Okay. So that means this. That means that f of x, which is 2x cubed, I'm just going to rewrite this over, 2x cubed plus 3x squared minus 8x plus 3 can be factored as x minus 1 times this quadratic, 2x squared plus 5x minus 3. All right? And then all you have to do is find the zeros of this quadratic. You can either use a quadratic formula or you could try to factor. If it's not factorable, then you have to use a quadratic formula. All right, so let's see if it's factorable. So we get x minus 1, and let's see what we get here. The only possibility for 2x is 2x and x, and the only possibility for -3 or 3 is 3 and 1. One has to be positive, one has to be negative. So let's see. I think what's going to work is that 3 has to go here, 1 has to go here. And since the middle term is a positive 5x, then that has to be positive, this has to be negative. And let's check. So we have 2x times x is 2x squared. A -1 times 3 is a -3. The outer is 6x, the inner is a -1x, and we get 5x. And there we go. So all I got to do now is set each factor to 0 to find the zeros. Set each factor to 0. So we have x minus 1 equals 0. We have 2x minus 1 equals 0. We have x plus 3 equals 0. And so x equal 1, which I already knew from here, right? And over here we get x to be 1/2, which was one of the zeros, which most students would not try first. And then the other one is -3, which we knew was a possibility. All right, so this cubic function had 3 rational zeros, and those are your rational zeros. So f of x has 3 rational zeros. Has 3 rational zeros, and they are 1, 1/2, and -3. All right. Now, I want to remind you about something because this could be important in one or two problems that we're going to do in a little while. So you see right here we factored, and you may say, well, could I use a quadratic formula? Yeah. So let's do that. Let's remind ourselves how to use the quadratic formula on this. So we have 2x squared plus 5x minus 3 equals 0. Okay? All right, so remember when using quadratic formula, you use a quadratic formula to find the solutions, to find the zeros of a quadratic equation. So a is 2, and remember 0 must be on the other side. B is 5. So remember b is the coefficient of x, a is the coefficient of x squared, and c is your constant. Remember all that? And so remember the quadratic formula is this, the opposite of b plus or minus the square root of b squared minus 4ac divided by 2a. And so x will equal the opposite of b. Well, b is 5. The opposite of 5 is -5. Plus or minus the square root of b, which is 5. I'm going to square that. Minus 4 times a, which is 2, times c, which is -3, all divided by 2 times a. And 2 times 2 in this case. So I get -5 plus or minus the square root of 5 squared is 25, right? 5 squared is 25. A -4 times 2 times a -3. So remember, negative times a positive times a negative is a positive. 4 times 2 is 8. 8 times 3 is 24. All divided by 4. 25 plus 24 is 49. So I get -5 plus or minus the square root of 49 over 4. Now remember, 49 is a perfect square, so the square root of 49 is 7. So I want you to notice that since 49 is a perfect square, you're going to rewrite it as -5 plus 7 divided by 4, -5 minus 7 divided by 4. -5 plus 7 is 2. 2 divided by 4 is 1/2, right? And that was one of them, wasn't it? Wasn't 1/2 one of them? Okay. The other one, -5 and a -7, is a -12/4, which is -3, and that was the other. All right. So that's how, remember how to use a quadratic formula to solve a quadratic equation. Okay. All right. So that was number 2. So it's very simple, isn't it? It's the more problems you do with this for practice, the easier it is to process. Okay. But again, it's that first little part here. We just lucked out because now remember, most students navigate to the integers and they'll try 1 first always, and we just lucked out that 1 is a 0. All right, but there is no easy way. It's just trial and error. You got to find one that works, and again, they may not they may not all work. I'm sorry, none of them may work. All right. Okay, so that was example 2. Okay, so let's look at example 3. So example 3, find all rational zeros of this polynomial function. All right, so remember the first thing you're going to do is you're going to list your possible rational zeros using the rational zeros theorem. So the possible rational zeros. All right, and so remember the numerator will be the factors of your constant term, so the factors of -6. The denominator will be the factors of the leading coefficient, so that'll be the factors of 2 since x cubed is the largest degree term, the factors of 2. And so this becomes, so the factors of 6 will be plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6, right? And then the factors of 2 would be plus or minus 1, plus or minus 2. All right, so let's go ahead and rewrite this in a better way. So the possible rational zeros are, okay, 1, remember, let's do each one divided by each one of these. So 1 divided by 1 is 1, so plus or minus 1. 1 divided by 2 is 1 half, plus or minus 1 half. Let's go to the 2. 2 divided by 1 is 2, plus or minus 2. 2 divided by 2 is 1. I already have it listed. Now let's go to the 3. 3 divided by 1 is plus or minus 3. 3 divided by 2, plus or minus 3 halves. And then let's go to the 6. 6 divided by 1, plus or minus 6. 6 divided by 2 is 3. I already have it listed. So it looks like these are the only possible rational zeros. So remember, in this lesson, all we're looking at is cubic functions. And so I have at most 3 real zeros. They could all be rational. They could be a combination rational real, and they could be a real and complex as well. All right, but all I'm interested in this lesson is the rational zeros, and all of our examples in this lesson, all of them will be rational zeros. Okay, so each one of these you're going to see 3 rational zeros. In the next lesson, that's where we're going to also look at, well, what if they're not all rational? So some of them could be irrational, and so you're going to see how to do that. Okay, so remember, there is no easy way of determining which of these is a zero. Again, most students will navigate to the integers. They'll try plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6 before they even attempt the other rational zeros that contain fractions. All right, so, and that's plus or minus 2 right here. Okay, so let's try 1. All right, see what happens. Now remember, we're using synthetic division, so descending order, there are no missing terms, so I'm going to have 2, 11, negative 7, negative 6. All right, let's see what we get. Right now on the 2, 1 times 2 is 2, add, we get 13, right? 1 times 13 is 13. Add, I get, what's that, 7? Nope, I'm sorry, 6, excuse me, 6. And then 1 times 6 is 6. There we go, we got 1. Our first try, right? First try, 1 is a 0. All right, so 1's a 0. So this means x minus 1 is a factor. Okay, so that means that I can factor this right here as this. So f of x is going to equal 2x cubed. I'll just go ahead and rewrite the function over. Minus 7x minus 6, and so that's going to be the linear factor x minus 1, which I got from here, times the quotient. Remember the quotient. All right, so what most students will do is they'll say, okay, this is x cubed, so this will be decreased by 1. So this will be 2x squared, 13x, all right? And so this becomes 2x squared plus 13x plus 6. All right, and so let's go ahead and factor this. So this will be factorable. Now you could use quadratic formula if you want to, just like we did it in a previous example, but it's quicker, if it's factorable, it's quicker to factor. So this becomes x minus 1, and let's see what this becomes. 2x, x, and it looks like I need this to be 6 and this to be 1, I think. So, yep, so that'll work. And the last sign's positives and the middle term's positive, so that means both of these are positive. Let's double check though. 2x times x is 2x squared. 1 times 6 is 6. The outer is 12x, the inner is x. I got 13x when I add them up. All right, and so to find the zeros, set each factor to 0. Set each factor to 0. And so I get x minus 1 equals 0, 2x plus 1 equals 0, x plus 6 equals 0. And I already found this. Remember, we already knew that one. We knew 1 was a 0. Over here, we get x to be negative 1/2, which was one of the possibilities, right? Negative 1/2. And over here we get x to be -6, which was also another possibility. So those are your zeros. So this function had 3 zeros. So f of x has 3 rational zeros. It can't have any more, right? It cannot have any more because the degree is 3. You have at most, there's a theorem you're going to learn that you have if the degree is 3 or 4, whatever it may be, but whatever the degree is, that's the number of zeros you will have. So I have 3 zeros, and there they are. They're actually rational. None are irrational, none are complex. So f of x has 3 rational zeros, which are x equal 1, -1/2, and -6. Okay? All right, so very simple, right? Not difficult at all. Now, let me just tell you what's going to happen in the next lesson. So remember when we got to this point right here, it was factorable. And so if it's a factorable, if we can factor it very easily, then you're going to get rational zeros. But what if it's not factorable? Then in that case, you would have to use the quadratic formula, which could give you either irrational zeros or it could give you complex zeros. Okay, if it's not factorable, then that's what's going to happen. You're going to get irrational or complex, and that's going to be the next lesson. So all I wanted to do in this lesson, let me just remind you, all I wanted to do in this lesson was to find all rational zeros of a cubic function. And in all of our cubic functions, all of them, the degree is 3, and all of them had 3 rational zeros. All right, and so remember your steps is very important. You go back and you follow these steps. Okay, finding the rational zeros of a polynomial, because it's going to be useful in another lesson coming soon. All right, guys, so that's going to be the end of this lesson.